Okay, so Kat has asked me to give you all some reminders or information about IPCC modeling, and so I've been thinking about in the context of this workshop what would be um, most relevant. And first of all, let me say that this title IPCC modeling, hence the inverted commas, is a little bit of a misnomer because the IPCC doesn't really do any modeling, right? So what they do is summarize the science, and in this case, summarize the modeling that other people have done. And that might sound a little bit like semantics, but it's actually really important because that means that whatever statements we lift from IPCC reports actually inherit the underlying assumptions of the modeling teams that have done those scenarios and built those models or whatever that those statements are based on. So for today, and so there's a lot of modeling that's going on all the time. Where can I do this? Where's my, here we go. Today I'll be mostly be focusing, or actually near exclusively focusing on the modeling that was summarized in the IPCC's special report on 1.5 degrees that came out in October 2015, and trying to unpack some of these things. It's just, I took 1.5 degrees to be most relevant because we are, a climate network and all these things, right? But net zero and phase out of greenhouse gas emissions plays a role in any scenario that actually tries to stabilize temperatures at some point. So in 2 degrees scenarios would also at some point have to go to net zero, and even 3 degrees scenarios, if they want to stabilize at that point, well, it just might not be in the next 100 years. But anyway, that's as a background. 1.5 degree is sort of the focus here. So what I've pulled out here is a quote from the IPCC special report on 1.5 degrees that is very, I don't know, well known, I guess, that many of you have either seen directly or seen the main points taken out of it. And I wanna like sort of like look into certain aspects of this code, because in first instance it sounds very straightforward, right? The summary says, in model pathways with no or limited overshoot of 1.5 degrees, global net anthropogenic carbon dioxide emissions decline by about 45% by 2030, reaching net zero around 2050. Right, so that seems to give us all the information that we need to get to a 1.5 degree pathway around the emissions. So one thing that already kind of jumps out from the text is that this statement is about carbon dioxide only. We know that there are many more greenhouse gases that we need to consider when talking about net zero or phase out of emissions, or when talking about emission reductions. This is, of course, a global statement. It is talking about the world. So the world reducing 45% of from 2010 levels by 2030 doesn't mean that every country is doing the same, right? So there will be some countries, some sectors that do more earlier, and so that other countries and other sectors can do less later. And the same is true with the net zero. If the world as a whole reaches net zero around 2050, that means that some countries have to get there first, and some countries have to go there, so that some countries can go there later. And those are questions around equity, but also around the availability of mitigation options that are limited in some cases or more abundant in others, or the availability of sinks capacity, so capacity to remove carbon dioxide from the atmosphere. What else? Then we have model assumptions. I talk about that more, that are all like in this neat sentence. There are many models that are behind this, that are summarized in this one sentence, and they all have their own assumptions. And then the sentence talks about limited or no overshoot So we already know that some of the scenarios overshoot 1.5, and that comes with its own risks in terms of irreversible effects and other things. And so we can think about that. And then other things that come to mind are question of accounting of LULUCF and sinks. I might not be able to get there. And the question of international offsets, right? If the whole world gets to zero around 2050, there's just no space for international offsets in that, because we don't have another planet that we can trade carbon offsets with, right? So there is the offsets question only comes into play in which country goes earlier and later, but not for the global statement. So yes, so that's the general idea here. And so as I said, the special report looked at 144 scenarios. Here's a link. You can to the Scenario Explorer. You can explore the scenarios with the Scenario Explorer. And 53 of those scenarios were low or no overshoot scenarios, and only 9 of those were actually no overshoot scenarios. So the statement that I just showed you is about those 43, right? Those 53 scenarios that have these 45% median reductions and the 2050 net zero CO2 date. One thing that I want to highlight here is because two of those 9 and another 5 of those 53 are from a study that I've led, and I'm mentioning this here because these scenarios the IPCC only summarizes scenarios that someone has built, right? So that again sounds like a trivial statement, but it is actually important, because when the reason why I got with a team into the scenario modeling stuff is that when the 5th assessment report from the IPCC came out, all of the scenarios were overshoot scenarios, and all of the 1.5 degree scenarios had large amount of carbon dioxide removals in it. And so the 5th assessment report had statements in it from the scenarios that 1.5 degrees is only possible with large scale carbon dioxide removal. And so we realized that if we want the special report on 1.5 degrees to say something different, to be able to say something different, those scenarios had to be developed. So we developed some scenarios that actually got to 1.5 without overshoot and got to 1.5 degrees without carbon dioxide removal. But this is just to say that that just the fact that scenarios are not included in this IPCC literature doesn't mean that they're important. They're impossible. For example, our scenarios that I mentioned ended up using a bunch of nuclear. That was not because we like nuclear, but because we didn't tell the model to behave any different in that particular study, because we were interested in carbon dioxide removal. We could have also, in a different study or an additional one, limited the amount of nuclear. That would have totally been possible, but now the scenario ensemble doesn't contain the scenario that gets away without nuclear and without CDR. It doesn't mean that it's impossible. So just thinking about that, these statements incorporate all these assumptions of the modelers. So always be careful with and suspicious about statements that say things like the scenarios say X and Y, or the models say X and Y. It's always based on specific study questions that specific modeling teams were asking themselves, and doesn't mean that all other scenarios are impossible. Okay, I'm spending too much time here, so I'm going to jump ahead. So this is a picture from the special report on 1.5 that shows some of the main types of scenarios. So these are 4 representative or illustrative model pathways. And what they show us quite clearly is that you can draw lots of different pathways that all lead to 1.5 degrees in 2100. So they all do that, but they differ quite substantially in terms of how much negative emissions or carbon dioxide removal they assume. So you have like virtually none or none in the P1 scenario to a lot in the P4 scenario. And what carbon dioxide removal essentially does is, under the same carbon budget, it allows the timing of the emissions to shift over time. So in the P1 scenario, we can see there's no carbon dioxide removal. And because of that, you need a very steep near-term emissions reductions. Whereas in the P4 scenario, where there's lots of carbon dioxide removal, there are very low near-term emission reductions. In fact, in 2030, in the P4 scenario with the lots of CDR, also carbon dioxide removal, emissions in 2030 are actually higher than in 2010, whereas in P1 they have to be 58% lower, so that the carbon budget can be made or can be observed, can be not is not breached, and so that is one of the relationships between carbon dioxide removal and near-term emission reductions is that more carbon dioxide removal in the later half of the century allows less stringent emission reductions in the near term, and so the question is, but the problem is, if today we embark on a scenario that looks like a P4 scenario, and then at some point later realize that all this yellow carbon dioxide removal is not possible, and carbon dioxide removal potential looks more like this in reality, then we are already out of, this pathway has already gotten out of our reach. So, and we will essentially condemn future generations to either breach the carbon budget that is consistent with the temperature that they would like to live in, or figure out some way of making this carbon dioxide removal happen, even if maybe they don't want it, because, because, for example, it takes a lot of land. Like in this area here, again, this is from the IPCC report, takes 7.2 million square kilometers of bioenergy crop production in 2050, which is roughly half of the land that is currently under crop production, mostly for food currently. So half of that we would need to use for bioenergy crops, and so I don't know where the food then comes from, and also for comparison, like the total land area of Canada is 9 million square kilometers. So it's quite a lot of area that would need to come under biocrops production, and in these scenarios. I'll skip this. Now, when we talk about net zero, one important question is net zero of what, right? So there's, I mentioned it in the beginning, there's the question of just carbon dioxide removal versus just greenhouse gas emissions. So here's an illustration that shows around this time here, this scenario has carbon dioxide neutrality, or net zero carbon dioxide, and net zero greenhouse gases only around this time, when the carbon dioxide removal is large enough to offset not only the remaining carbon dioxide emissions, but also the carbon dioxide equivalent of the remaining non-carbon dioxide greenhouse gas emissions. And this is important because at the point where you have net zero net zero CO2, the global warming roughly starts to stabilize, right? So that's when the warming stops to go up, but it doesn't go down until you start to have net zero greenhouse gas emissions. Then global warming starts to peak and then to decline once you achieve net negative total greenhouse gas emissions as the carbon dioxide is removed from the atmosphere. So those are important questions, whether we're talking about CO2 or greenhouse gases. And so this is just like numbers. I'm not going into too much detail. Those are just the numbers that are already referred to when talking about the carbon dioxide removal and the stringency of the pathway. So if we have the more carbon dioxide removal we have later in the century, and the more overshoot we will get, but also the less stringent our near-term emission reductions are. So this is sort of what this was supposed to show. and I'm running out of time. That's why I'm skipping ahead a little bit. But the same is also true for the phasing for the timing of the phase out or the net zero year. In below 1.5 degree scenarios, you have it roughly around for CO2 in the late or in the mid 40s, and for limited or no overshoot scenario as a group around 2050. So that's the number from the top level statement that I showed in the beginning. But even with high overshoot, which also means high removal, it actually doesn't go much later. So for CO2 in total, you gain only another 2 years. But for all greenhouse gases, it makes also makes a little bit of a difference. But one thing that is very interesting to note is that for many of the below 1.5 degree scenarios that don't require any carbon dioxide removal, there's actually no complete phase out of all greenhouse gases required because of the stringent reductions in CO2 early on. And so there is no need to ever offset the residual non-CO2 greenhouse gases while still meeting the 1.5 degree scenario, and that is due to the early ambition and the stringent reductions, and thus not breaching the CO2 budget. So I actually don't really know when I started, but let me maybe just, so I don't know how much time, if any, I have left. So if someone can give me a hint on that, that would
be sorry, I've been chatting. Maybe you can't see the chat. We're at time.
Okay.
So if you have a couple key points to make.
Yeah. So. Okay, so this is a key. This is actually a key point, and that is about It's about LULUCF accounting. Again, sounds a little bit geeky, but in the climate models actually use different methods of accounting for land use sinks, and so the emissions inventories that countries make overestimate sinks for various reasons. So we can't even use the numbers that directly come from the global climate models and apply them to our national inventory numbers, and because that will just give us the wrong number. So if the IPCC says 2050 phase out or 45% reductions, we actually can't just apply that to our national totals because that won't add up to the same warming. So it has to be a little bit earlier and a little bit more stringent. So that's an important one. We need to think about these accounting things. And yeah, this is something showing the same thing in a different way. And I'll skip this. Yes, and this. I'm sorry that I was too wordy. I had too much ambitions for these 15 minutes.
Oh, that's okay. Although I am really curious about your checklist for rigorous and clear net zero plans. But that's maybe something for us to pull into our deeper conversation later on. Thanks so much, Christian.